Hi guys, hope everyone is doing well. So today we're going to be doing a simple Euclidean problem of which we're going to try and attempt it and solve it, right? Let's begin. So firstly, before everything, we have to read the question statement because obviously you have to understand what is going on. Even though you have the edge of taking the question, please just read the question statement, right? So the question statement reads as follows, right? In the diagram, E, F, G, H, and I are points on the circumference of the circle such that EI is parallel to FG and FI and GH meet in J, right? As you can see here, KFL is a tangent to the circle at F, right? So this is the tangent that they're talking about right here, right? Right, perfect. Then angle F1 is equal to 68 degree and angle J is equal to 20 degree, right? So F1, this is F1 here, and J, right? So as soon as you know that, you're good to go. Right, the first thing, determine IY. So to make our life easy, because Euclidean geometry in its own needs logic, right? And you have to be able to see what is going on. I usually suggest that we use Dr. Cape Town, right? So Dr. Cape Town, right? DRCPT. Now what this means, it's just a shortened way of all of the theorems that we know, right? So the D stands for diameter, the R radius, the C cyclic quad, the P parallel lines, the T tangent. So what does this mean? So what this means is this. So if there's a theorem, like if there's a theorem about the diameter here, or maybe if we're told about the diameter in the question statement, this means that we are going to apply the theorems that require what? A diameter. So it makes our life easy so that we know which theorems we're going to be focused on, right? So yeah, so let's begin here. Is there a diameter? No, there's no diameter, so there's no diameter. Is there a radius? No, because if there was a radius, there may be a diameter a bit there. So a cyclic quad, is there a cyclic quad? Yes. Where is this cyclic quad? The cyclic quad is this one, F, I, H, G, and F, right? F, I, H, G, right? That's the cyclic quad. Unless if there's a second one that I don't see, but yeah, I think that's the only cyclic quad there is here, right? And is there parallel lines here? No, there's no parallel lines, unless if let's see, wait, yes, there is parallel lines. I'm very sorry, they said it here such that EI, which is this one here, I didn't draw the lines, they are parallel to each other, right? Which is why it's important to read the question statement, right guys? Perfect. Now since we know that they're parallel lines, this means that we may use what? Fun, right? FUN, corresponding, alternate, and cointerior, right? Tangent, tangent, right? So this means that once you see that there's a tangent, you're gonna play around and try to find the tangent. You're gonna say tan chord, let me use a different marker. I'm gonna say 10 chord alternate back home, right? I1 is equals to 68 degrees. Oh, we've even begun to solve the problem. But then yeah, so that's how we're gonna do it. So let's do it right here and say number one, solution, right? And I1, angle I1, it equals to 68 degrees, right? 68 degrees, Y, 10 chord, right? You can write 10 chord theorem. No one is stopping you. And number two, they say angle F3, right? So angle F3, let's see, how can we find angle F3? Now to find angle F3, we do know that we have parallel lines, right? So I can just say and this one, right? So this means that it's equal to what? F3 is equal to I1, right? So this would mean that angle F3 is equals to angle I1, which is equals to 68 degrees. Why? Alternate angles. Which parallel lines did you use? The ones of EI and FG, right? Perfect. Now for the third one, since we are halfway through the problem, so we see that having this, it guides us to be able to see which theorems we're going to be applying, right? I hope everyone is paying attention to that also. So for angle H1, which is this one here, how are we going to find it, right? So for that one, we now know what is F3, right? So how about we use the exterior angle of a cyclic quad, right? Since this is a cyclic quad, you see. So this means that angle H1 is equals to angle F3, which is 68 degrees, right? And the reason it's going to be exterior angle of cyclic quad, right? Good. Now for I2 now it's going to be slightly different, because from now I'm sure everyone is like, why is everything 68 degrees? Like I said in the beginning, this is a simple question. It's just to, you know, give ourselves that little bit of confidence, you know, before we attempt the big problems, right, which are going to be following in the next videos. Please stay tuned. Right, so for number 4, I2, to find I2, we are going to apply the exterior angle of a triangle, right? Why? Because I can see here, even me, that we have a triangle, right? And H1 and J, we have them. Remember that an exterior angle of a triangle states that I2 is going to be equal to the interior opposite angles, right? So the sum of the interior opposite angles, meaning that H1 plus J is equals to I2. That's the theorem itself, right? It's not a theorem, but yeah. So that's what it says. Perfect. So we are going to say angle I2 is equals to 68 degrees from the H1 plus 20 degrees from the J. Y exterior angle of a triangle. Exterior angle of triangle. Then angle I2 is going to be 88 degrees, right? Perfect. I'm very sorry for my handwriting, guys. You know that I'm not good in writing, but then yeah, as long as you listen to my voice, I think it should be good. And for number 5, we then have G, right? Yeah, angle G. How can we find angle G? Right? Everything here is connected. What we did before, we are going to use it. Now let's focus on what we did for I2. Since we found I2, then this means let's just use what? Angles, opposite angles of a cyclic quad to find G, right? So that's what you're gonna do. So angle G plus I2, angle I2 is equals to 180 degrees, right? The reason it's opposite angles of a cyclic quad, right? So this means that angle G is equals to 180 degrees minus 88 degrees, right? Of which we are gonna get 92 degrees. Perfect. Well guys, we have reached the end of this video. This was a short, interesting question just to try and train ourselves to get used to Dr. Cape Town, right? So in the next couple of videos that will be posted on this YouTube channel, we are going to be applying Dr. Cape Town on some problems, right? And Dr. Cape Town itself, it helps when you find that it's a rider. A rider is a problem having multiple theorems, right? That's how you can apply it to be able to see what is going on. And I honestly recommend that you use pencils or markers when you're practicing in order to see what is going on. Because if you get in blindly, you're not going to see it, right? In the next video that we're going to do, I'm honestly and most definitely going to be showing you guys how important Dr. Cape Town is, right? And I hope that you enjoyed this one, and I'll see you guys in the next one.